Welcome to our exploration of arcuated structural systems, where we delve into the fascinating world of arches, vaults, domes, and more. From the Colosseum in Rome to the Taj Mahal in India, these remarkable structures have stood the test of time, testaments to human ingenuity and architectural prowess. These systems have shaped some of the most iconic architectural marvels throughout history and continue to inspire modern design. Join me as we uncover the secrets behind their enduring strength and elegance. Our journey begins with one of humanity's earliest attempts to overcome the limitations of gravity, the Corbelled System. Imagine early builders stacking stones, each layer projecting slightly inward, like a giant staircase reaching for the sky. This technique, while seemingly simple, was a stroke of genius for its time. By carefully arranging stones or bricks, each layer cantilevering slightly inward, ancient builders could create openings and spaces that would have been impossible with simple post and lintel construction. The weight of the structure is transferred outward and downward through the corbels, relying on the principle of compression. This method allowed for the construction of impressive structures such as the stepwells of India and the towering temples of the Mayan civilization. The stepwells provided access to precious water sources, their descending passages offering respite from the scorching sun. However, the Corbelled System had its limitations, with spans being limited and structures vulnerable to lateral forces. Despite these limitations, the Corbelled System represents a pivotal step in the evolution of structural engineering. Moving beyond the Corbelled System, we encounter a structure that defines much of architectural history: the arch. A simple curve of stone or brick, the arch harnesses compression, transforming the way we build. It distributes load outward and downward, transferring forces to the supports. This eliminates tensile stress, making the arch strong and stable. From doorways to Roman aqueducts, the arch has proven its versatility and strength. Imagine taking the elegant curve of an arch and extending it, creating a continuous arch ceiling that stretches over a vast space. This is the essence of the vault, a testament to the architectural ambition to enclose and define ever larger spaces. The vault, like its predecessor the arch, relies on the principle of compression, transferring loads outward and downward to the supporting walls or piers. From the soaring heights of Gothic cathedrals to the utilitarian spaces of Roman bathhouses, the vault has been employed to create a sense of grandeur and awe. The rib vault, with its exposed ribs tracing the lines of force, became a hallmark of Gothic architecture. The barrel vault, a simple continuous arch, was favored for its strength and simplicity, while the groin vault offered a more efficient way to channel loads to specific points. Despite the complex construction process, the vault provided architects and builders with an unprecedented ability to create vast, awe-inspiring spaces. Rising above the cityscape, the dome stands as the pinnacle of arcuated structural systems. Imagine a perfect hemisphere, floating effortlessly above, its smooth surface concealing intricate forces. The dome harnesses compression, transferring loads evenly along its curved surface. This strength creates vast, unobstructed spaces, bathing those below in a celestial glow. From the Pantheon to Hagia Sophia, domes have graced history's iconic structures. Despite complexities, the dome remains an enduring symbol of architectural ambition. In the intricate dance between form and function, architects often face the challenge of transitioning from square or polygonal bases to the circular base required for a dome. Enter the squinch, an ingenious structural element that bridges this geometric divide with elegance and ingenuity. Imagine a series of small arches, or corbels, placed diagonally across the corners of a square base. These arches, known as squinches, gradually transform the square into an octagon, creating a stable platform upon which a dome can rest. The squinch, by distributing the dome's load evenly to the base, allowed for the creation of larger and more elaborate domed structures. From the mosques of the Islamic world to Byzantine churches and even Indian temples, the squinch became an indispensable tool for architects. The squinch, though often hidden from view, played a pivotal role in the evolution of domed architecture. As architects sought ever grander spaces, a new structural innovation emerged, one that would revolutionize domed architecture, the pendentive. This elegant solution to the challenge of supporting a dome over a square base combined structural ingenuity with a sense of ethereal lightness. Imagine four curved triangular sections like slices of an orange nestled between the circular base of a dome and the corners of a square or polygonal room below. These are pendentives, and they work by transferring the dome's weight to four supporting piers, allowing for a sense of openness and grandeur unmatched by previous methods. Unlike squinches, which transition from square to octagon, pendentives create a smooth, continuous circular base for the dome. The Hagia Sophia in Istanbul stands as a testament to the elegance and structural brilliance of the pendentive. The construction of pendentives required advanced engineering and precise calculations. Despite these challenges, the pendentive became a hallmark of Byzantine architecture, influencing architectural styles across the globe. As we've journeyed through the world of arcuated structural systems, from the humble corbel to the soaring dome, we've witnessed the ingenuity and artistry of countless builders and architects throughout history. Arcuated systems represent significant advancements in architectural and structural engineering, allowing for grander, more durable, and aesthetically pleasing spaces. These systems form the backbone of some of the most iconic architectural achievements in history and continue to inspire modern design. Thank you for joining us on this journey through the world of arcuated structural systems.